Okay, this video is meant to help you guys write linear equations using point-slope form. We can actually get out of this by just using slope-intercept form as well, and I will do a video just using slope-intercept form also, but check that. There should be a link to that in the explanation of this video. So I'm doing this video specifically because I noticed students in all different levels of mathematics, they actually have a hard time writing linear equations. So I'm going to do 3 different examples because there are different ways that you could be asked to write the equation of a line. But let's just review really quick the different forms of linear equations. The point-slope form, which is exactly what it sounds like. It is an equation that actually utilizes a point, any point, and no specific point, and then of course needs the slope. So y minus y1 is m times x minus x1. So x1 and y1 are the x and y coordinates of a point, and m is the slope. Then we have slope-intercept form, which is the most popular form. You have to know this form, which is y equals mx plus b. And this one actually is exactly, again, what it sounds like. It gives a slope and an intercept, specifically the y-intercept. B represents the y-intercept, and m represents the slope. And the only way that you get the slope and the y-intercept, if you're in this form, is if y is isolated on the left, specifically. Then we have what's called standard form. Okay, and again, ax plus by is equal to c. Nothing really specifically can you gather from this form. If we're in this form though, a cannot be negative and it cannot be a fraction. So here, every time we write the equation of a line, you're going to need a slope and a point. Okay? A slope and a point. Always need a slope and a point. Now you could be given the slope and a point. You could be given 2 points. You could be given some information about the slope. For example, perpendicular, parallel lines. But let's just start with, write the equation of the line through the points. Just -2, 3, and 5, -1. Okay, so basically through 2 points. Neither one of these points are special because there's no 0 as our x-coordinate, meaning if 0 were the x-coordinate, then we'd have a y-intercept. And I'll do an example of that in a second. But the first thing that we're going to need is the slope. And I don't know if you guys remember your slope formula, but it's change in y over change in x. y2 minus y1 over x2 minus x1. So in other words, I'm going to take my second y-coordinate, -1, minus my first y-coordinate, 3, and divide by my second x-coordinate, 5, minus my first x-coordinate. Notice that the minus sign in the formula does not take the negative away, okay? It's minus a negative number on the bottom here, so it's a double negative. Okay, -1 minus 3 is -4. When I do 5 minus -2, a minus minus becomes a plus, so this is 5 plus 2, or 7. So the slope of this line is -4/7. So now I have 2 random points, and I have a slope. So because it's not an intercept, not a y-intercept, I'm going to go and use the point-slope form of a linear equation to write the equation of this line. And I can choose whichever point that I want because if both of these points lie on this line, they both are going to work in the equation. So I pick whichever one is more easier to look at, that I'm more comfortable with, whatever. In this case, neither one is special, neither one, has a intercept, neither one is all positive, so I'm just going to pick any one here. I'm just going to pick the -2, 3, and I'm going to plug it into this formula. So let me write it down again. Y minus y1 is equal to m times the quantity x minus x1. So y is my variable, minus y1, which is the y-coordinate of the point that I chose, minus 3, is m my slope, which I just found to be -4/7, times the quantity x, my variable, minus x1, which is the x-coordinate of the point that I chose, so minus -2. Okay, so the first thing that I notice is that I have a x minus -2, which becomes an x plus 2. So here's the equation of the line, basically done in point-slope form. Now, more than likely, you're not going to stop at this point. Most of the time, we represent the linear equation either in slope-intercept form or in standard form. So I want to show you how to convert this into slope-intercept form and also into standard form. So the first thing that I'm going to do to go into slope-intercept form is I need to isolate the y. So I need to maneuver this and isolate the y on the left. So the first thing is always to distribute the slope. So I have y minus 3 is equal to, I have a negative 4/7 times x. Negative 4/7 x. This is a negative 4/7 times a positive 2 over 1. And when you're multiplying fractions, you multiply across the top, negative 8, multiply across the bottom, 7. Okay, so I distribute that negative 4/7. Then I want to isolate the y on the left. So now that I have no parentheses on the right-hand side, I can simply just add 3 to both sides so that I can isolate y on the left. So I have negative 4/7 x. And now I'm going to combine these two. I have a negative 8/7 plus a 3 over 1. And when I'm adding fractions, I need a common denominator, so that would be a 7. So this is going to be a negative 8/7 plus a 21/7, which on the bottom, right, keep the bottom, work the top. I get a negative 8 plus 21, which is a 13 over 7. So this part becomes plus 13 over 7. Now I'm in slope-intercept form. And now that I'm in slope-intercept form, I can identify the y-intercept, which in this case is 13/7. And it could be a fraction. Don't be scared of the fractions. Okay, so now I want to show you how to convert from slope-intercept form to standard form. So this is the process that you would go in. If you're asked for standard form, when you're writing the equation of this line, you're going to likely go through slope-intercept form to get there. And so now I'm going to go into standard form, which I have my x term on the left leading, my y term following, my equal to sign, and then my constant on the right. So the constant has to stay on the right, the x term has to move, the y term is going to stay, so that I convert it into standard form. So in order to move this over across the equal sign, I have to add the whole thing. So plus 4/7 x to both sides. So 4/7 x plus y is 13/7. So I'm very close to standard form. I have my x term, I have my y term, my equal to, and my constant. The only thing is that, remember, I cannot lead with a fraction. It has to be a positive whole number here. So how do I clear out the fraction so that it's leading with a positive whole number? Anytime you want to clear a fraction, you're going to multiply by its denominator. But if I multiply this term by 7, everybody gets multiplied. So that 7 is going to distribute everywhere. So it's going to cancel with this denominator, leaving 4x. And then it's going to get multiplied by this y, so plus 7y is equal to, when I multiply this 7 by 13/7, it's going to cancel with the denominator. And I'm just going to get 13 on the right. And now I have my linear equation in standard form. Okay? 3 different representations of the same equation. And these are all representations of the equation that goes through these 2 points. Point slope form, which I went through first because I didn't have any slope-intercept, or I didn't have any y-intercept here out of these 2 points. I manipulated from point slope form into slope-intercept form by isolating y on the left, which is a more common form. And then I manipulated from there into standard form. More than likely, you're going to have to manipulate into slope-intercept form or standard form at the end of the day. Okay, you're going to typically be asked to write the equation of a line through these points in slope-intercept form or in standard form. Okay, so this is the first example. Let's look at another one. Number 2. Let's do the equation of the line through -4, -2, and 0, 3. Okay. Now, again, I have 2 points that are given to me. I want to write the equation of a line. Again, I'm going to need a slope and a y-intercept. So in this, a slope and a random point. It doesn't have to be a y-intercept. And I have 2 points here, so I have to find the slope. And again, it's change in y over change in x. y2 minus y1 over x2 minus x1. So this is the second y coordinate, which is 3, minus the first y coordinate, which is -2. Over the second the second x coordinate, 0 minus the first x coordinate, -4. and then I simplify. Double negative is a plus, so 3 plus 2 is 5 over 0 plus 4, which is 4. So 5/4 is my slope for this line. Now the nice thing about the points that we're given is the moment I see an x-coordinate being 0 is the moment that I know that I have a y-intercept, which is a point that crosses the y-axis. So if the x-coordinate is 0, if the x-coordinate, let me write that for you, if the x-coordinate equals 0, you have a y-intercept. And you have to learn how to identify that because it'll simplify your situation. Once you have a y-intercept, this is the b in my slope-intercept form. So I can actually jump straight to y equals mx plus b because of the point that they gave me. Y equals m, which is 5/4, x plus b, which is 3. And I know that b is 3 because this x-coordinate is 0, which implies a y-intercept. So this is, again, the equation in slope-intercept form. So I'm going to also show you how to convert that into standard form just in case you're asked for that. And it's the same thing. I got to get my x term to the left-hand side. So it's got to move over. And if I'm moving it across the equal sign, I'm going to do the inverse operation. So in this case, I'm subtracting the whole thing. So I have a negative 5/4 x plus a y is equal to a 3. Again, this is not standard form if this term leads with a negative or a fraction. So I have to clear out, in this case, the negative sign, and I have to clear out the fraction. I have two things that I have to do. To clear out the fraction, we said we're going to multiply by the denominator. So in this case, we're multiplying everything by 4. But I'm going to also cancel out that negative sign. So anytime I want to get rid of a negative, what do? I multiply by another negative number. Negative times a negative is positive. So if I multiply by negative 4, I'll clear the fraction and I'll clear the negative. So I have a negative 4 times negative 5/4. Negative times negative is positive. The 4 is going to cancel with this 4. So I'm left with a positive 5x. Negative 4 gets multiplied by y minus 4y. And the negative 4 also gets multiplied over here, giving me negative 12. And here is the equation of this line in standard form. Okay. I want to just do one more example, writing the equation of a line. And this time, you're writing the equation of a line through the point 4, 6, perpendicular to the line 3x minus 4y is equal to 6. Now, not everybody has done perpendicular and parallel lines. So if you have not, I need you guys to check out in my video talking about that. But once you hear parallel lines, and this is the symbol for parallel lines have equal slopes. So the moment you hear either parallel or perpendicular, it's telling you something about the slopes of the two lines. Automatically you think slope. Parallel lines have equal slopes and perpendicular lines have opposite reciprocal slopes. Okay? So if you don't already know that, that's just a little review. But I'm going to do the same thing that I've been doing. I'm going to write the equation of this line. I'm given different information, but I still need a slope and a point. Have the point, I need the slope. So the slope's going to come from here. I know that I'm perpendicular to this line. Perpendicular means I am intersecting at a right angle, which is a 90-degree angle. Sorry guys about this focusing. Okay, so first of all, I need to find the slope of this line to find the slope of my line. So to find the slope of this line, I have to put it in slope-intercept form because standard form doesn't give me any information. So I need to isolate y. So the first thing I'm going to do is bring this 3x over so that I can get my y term alone. Okay? Then I need to isolate y, and I'm being multiplied by negative 4 right now, so everybody has to get divided by negative 4 to get y alone on the left. So I have y equals negative 3 over negative 4, which is 3/4 x, positive 6 over negative 4, which is a negative 3/2, simplifying fractions. And the slope of this line is 3/4, right? Once I'm in y equals mx plus b form, the coefficient in front of x is the slope of the line. Now this is not my line. My line goes through the point 4, 6, and has a slope that gives me perpendicular to this one. So if I'm perpendicular to this, then the slope is the opposite reciprocal. So if it's the opposite, if this is positive, then my slope is negative. And if it's the reciprocal, that means just flip the fraction. So if this line has a slope of 3/4, I'm going to flip it and make it the opposite sign to get the slope of my line because I'm perpendicular. Opposite reciprocals. And now I'm back to where I was before, where I have a point, a random point, and the slope of my line. And I can go ahead and write the equation. And I'm going to start with y minus y1 is m times x minus x1, because this is not a special point. It's not a y-intercept. So it's just an x-coordinate and a y-coordinate. So I'm going to go through point slope form first. Y minus the y-coordinate is equal to m times x minus the x-coordinate. Convert into slope-intercept form. So the first thing I'm going to do is distribute that slope to get rid of the parentheses on the right. So I'm left with y minus 6 on the left. Negative 4/3 times x is negative 4/3 x. Negative 4/3 times negative 4/1. Multiply on the top, I get a positive 16/3, right? Then isolating y, I have to add 6 to both sides. So I get y equals negative 4/3 x. I'm going to combine these two terms. I have a 16/3 plus a 6/1, which now needs a common denominator, which in this case would be a 3. I have a 16/3 plus an 18/3, which is going to give me a 34/3. Keep the bottom, deal with the top. Keep the bottom, add the top. So plus 34/3. And now I'm in slope-intercept form, and the y-intercept of this line is 34/3. Don't let fractions scare you, they happen. Okay, it could be nice numbers or it could be fractions. Last but not least, to convert into standard form, because you could be asked for slope-intercept form or standard form, know how to do both. Here I am in slope-intercept form. So if I were asked to write the equation in slope-intercept form, I would be done. If I were asked for standard form, I have a little bit more work to do, right? I need to get my x term to the left. Same thing, same process over and over again. This time I'm going to add the 4/3 x to both sides to move it across the equal sign. 4/3 x plus y is 34/3. Think about what I should multiply this by so that I can get rid of the fraction in front of x. The nice thing is that it's not negative, so I don't have to clear a negative sign. I just have to clear out the fraction. And I'm going to multiply by, you guessed it, 3. To clear out a fraction, I multiply by the denominator. When I multiply 3 times 4/3, the 3 is going to cancel with that denominator, and I'm left with 4x. 3 times y plus 3y is equal to 3 times 34/3. The 3 is going to cancel with this denominator, and I'm left with just 34 on the right. 4x plus 3y, oops, is equal to 34. Write that over. 4x plus 3y is 34, and here is my final standard form of this linear equation, okay? So write the equation of the line through the point 4, 6 perpendicular to this other line. If you're told perpendicular or parallel, you have to find the slope of this other line to get the slope of your line through your point, and then do the same thing that we just did. If this is not a special point, meaning if it's not a y-intercept, you have to go through point slope form first, manipulate into slope-intercept, and from here to here is always distribution of the slope and then bringing that number over to isolate y. And if you're asked for standard form, manipulation from slope-intercept to standard is to just bring this x term to the other side of the equal sign to the left, and then make sure that you don't lead with a negative or a fraction. Don't forget, perpendicular lines have opposite reciprocal slopes. Parallel lines have equal slopes. Typically, if we're talking about parallel perpendicular lines, automatically we think slope. So this is a hidden way of telling you the slope of your line. Okay, so again, what do we need when we write the equation of a line? We always need a slope and a point. You can either be given 2 points, you can be given information like this, perpendicular or parallel to another line, Or you can be given the slope and a point directly. At the end of the day, it's always a slope and a point. Okay? If you guys have any questions, let me know. Good luck.